In this video, let us discuss the equation for electric current through a metallic conductor. Now consider a metallic conductor of length L and area of cross section A having n number density of free electron. The length is L, area of cross section A, n, small n, specifically small n, shows the number density of free electrons. Number density, that means number per volume of the material. Now, as we consider this metallic conductor under normal state itself, we are having enough and more free electrons present, but still they are not able to produce electric current. The reason is all those free electrons will be at random motion, and therefore the net flow will be zero. Now, to produce electric current in this conductor, we will be connecting this conductor with a source of electricity. I mean a battery. This battery is having positive over here and it's negative over here. Just after connecting this, you can find that there is a current flowing through the conductor in this direction. From the positive terminal of the battery through the conductor to the negative terminal, and it flows through. Now, just after connecting a source here, a battery of potential difference V volt, an electric current is set up in this one. Now, let us assume how that flow is possible. Now, see this cross section is connected to the positive of the battery, and therefore this phase acts as positive and this phase acts as negative. Between these two ends, there is a potential difference of V volt. And in electrostatics, we studied potential difference is something that makes the electric charges to flow. Now here we are coming across that statement, we are proving it. Now when this plate is positive and this is negative, what happens here is there exists an electric field between these two ends, and that field E will be acting around this direction. That means from the positive plate to the negative plate, there exists an electric field E. And that electric field E will be equal to potential difference by length of the conductor, we can say. Now, as the electric field is set up along this direction, the free electrons which are flowing at random initially before connecting the circuit are now forced to move against the direction of the electric field. That means the free electrons, they are present all through the conductor, are now moving against the direction of the electric field, and you all know the reason. Now, as the electrons are made to flow along this one particular direction, they flow in a streamlined manner, and therefore that constitutes an electric current. Okay? Now, these free electrons, as they move from negative phase to the positive plate through this one, that constitutes electric current, and that electric current I therefore will be equal to number of charges flowing per time. Okay? Number of charges into charge of an electron divided by T. Or let us say with the first condition that I equal to Q by T. Q equal to total charge flowing per time. And now we can substitute N, where N is the number of free electrons, and that number of free electrons in this case will be equal to small n into, that is capital N equal to small n into volume of the conductor, because small n is the number per unit volume. So in this volume of the conductor, how many free electrons are there? Therefore, this equation will be small n into A into N into E divided by T. Now, in this state, we introduce a new term here, that L by T. We take an average velocity, and therefore I can be written as small n into E into A, that is these three, and L by T I told you is an average velocity. I take it as V subscript D. Now, this is the equation for electric current, we can say, where I introduce a quantity called Vd, we call it as drift velocity of the free electrons. Drift velocity of the free electrons. Now, what is drift velocity? Let us see. When all these free electrons are made to move along this particular direction, there are immovable ions and atoms in the material, and these electrons will be colliding those material, and after collision again moving, again collision, like that. Multiple collision will be taking place in its motion, and therefore the electrons will not accelerate effectively due to this multiple collision. They all form to move with a average velocity, and that average velocity is called drift velocity. The definition for drift velocity, we can take it as, it is the average velocity with which the free electrons are moving through the conductor to make the electric current to pass through it. Okay? It's the average velocity. So when the electrons are moving through this conductor, they are not accelerating. The field will be accelerating it, but they cannot accelerate due to the multiple collisions. Therefore, they are all formed to move with a steady or average steady speed, and that speed is called drift velocity. And in this case, in the case of metallic conductor, the drift velocity is of the order of 10 raised to minus 5 meter per second. It is an approximate value. It is a very, very small value. Next, we see the things in the next video. That's all.